Morning, everyone. Today we're going to do section 6.2. But before we do that, actually, I'm going to extend yesterday's ideas from section 6.1 just a little tiny bit, as this is something that's not actually in the textbook, but a little extension to help you with these like flipping coin problems. So if I give you a problem like what's the probability of getting, let's say, 3 heads in 4 flips? So last night's homework, pretty much all we learned was the basics. Like you could list these out in essence. So they asked you to do the sample space. So you could go heads, 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 heads. That's one possibility in 4 flips. And then heads, 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 tails, and so on, right? You could do this with a tree diagram. It would help. But there's still going to be 16 outcomes. The way I know that there's 16 outcomes is remember that fundamental principle of kind of you can just multiply the outcomes together. So there's 2 outcomes on the first flip, 2 outcomes on the second flip, 2 outcomes on the third flip, and 2 outcomes on the fourth flip for 16. Just multiply them together. So if this problem gets extended and it's like the probability of 7 heads in 13 flips, certainly you don't want to list all these out, right? It's just too much work. So I'm going to show you a little shortcut for this little kind of cool math. I'm going to go back to the first problem. And the idea in the first problem is this. If we know that there are 4 flips, we know that there are 16 total outcomes. The main question boils down to how many different ways are there for me to get 3 heads? So one way to get 3 heads would be the way I have it written right here, right? Head, 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 then tails. But it could also be heads, then tails, then heads, and then heads, right? This is a pretty simple problem because I asked for only 3 flips. You know, the only other outcome. So here's 1 outcome. Here's 2 outcomes. And then we could just move that tail, right? So I kind of did this a little bit out of order, but we got the tail in the last spot. We got the tail in the second spot. The tail could go in the first spot. Or the tail could go in the third spot, right? Heads, heads, tails. So there's only 4 ways for this to happen. Not too hard to count those, but when it gets a little bit trickier, it's just too much work. So the basic idea is this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we know there are 2 to the 13th total outcomes. So that's going to be the denominator in our probability problem. Again, it's just 2 times 2 times 2 times 2 times 2, 13 times. So now the question boils down to, how do I get these 7 heads in these spots? I could start listing. Might drive you a little bit nuts, but 1, 2, 3, 4, 5, 6, 7 heads. The rest are tails. Then I could just start moving these heads. It would be a disaster. It would take forever to count them. But there's a nice little mathematical formula for this that you actually probably learn in Algebra 2. And it's called the combination button on your calculator, or the choose button. Because basically what we're doing is we're taking 13 spots, okay, 13 spots, and we're choosing 7 of them to put the heads. So it's 13 spots, and we're going to choose 7 spots. There's a little mathematical formula for this. I'm not going to actually show you right now. We're just going to show you how to do it on the calculator. So on the calculator, the way this calculator works, it's this notation. You may have seen this before. It's 13, choose 7. That's the notation for that. So the answer to this problem is going to be 13, choose 7. So there's 13 spots. We're choosing 7. That's just going to tell me how many different places I can put those heads. Over 2 to the 13th, that's the total amount of outcomes. So the problem boils down to, how do I find that number? So let me move on over to my calculator real quick here. And I will show you how to do that on your calculator. It's a really easy process. We're going back to that math button. Sorry about the blur here. We're going back to that math button right here like we did yesterday. So we're going math. It's also probability. So we're going to scroll over here to probability. But we're going to use this button right here, the N, choose R. C is for choose or combinations. P is for permutations, which you may remember those also, which we'll talk about a little bit later. Permutations is when the order makes a difference. In this case, it doesn't. So I can't quite push this button yet because I got to give it a command. So I'm going to go back to the beginning. I need to type in that 13 first. So if I want to do 13, choose 7, just like I had written down before. It's 13. Then you go math, probability, choose, and then you type in that 7. So 13, choose 7, and there's 1,716. So I'm going to come back to so that's the button you're going to use. The first number is how many spots there are, and the second number is how many you're choosing. All right. So if I go back to show you here, we can finish up this problem now. I got my 1716 now written in there. Over 2 to the 13th, back to my calculator, just do that little math, 1716 divided by 2 to the 13th, and I get 20.94%. Okay, typically in these problems, we write these as percents because they're probability questions. They make more sense to have them in percents. But that's just a little extension for how to extend this problem if there's a lot of flips, that sort of thing. All right, so that was the extension from last night. Give me a second here to move on to 6.2. We're going to go to 6.2. So section 6.2 introduces some mathematical formulas for you. The first one's called the addition rule, which we'll talk about in a second. So we're going to talk briefly about the word or in math. In last night's homework, I think you had a problem that said, for the dice problem, that was what's the probability of getting a 7 or an 11. And probably without even thinking about it, you probably just added those two together because, well, either it's a 7, which has so many different outcomes. So for a 7, it's 1 and 6, 6 and 1, 2 and 5, 5 and 2, 4 and 3, 3 and 4. So there's 6 7s. So that would be 6 out of 36. And 11 is just 5 and 6, 6 and 5. So 2 out of 36. You probably just added those two together and got 8 out of 36, which was the right answer, without even thinking about it. So there's a rule that allows us to do that, but we can't always do that. So it's important to know this word or in math. So in the English language, we typically think about the word or as meaning one or the other, kind of like either or. Either I'm going to go to McDonald's or I'm going to go to In-N-Out. But not both, right? It's either one or the other. But in math, it can be both, right? So just a little important thing to know here is that in math, that word or means one or the other or both. Again, not typically the way we think about it, that one. So the addition rule, which is actually on your note sheet, says this. This is exactly what you did last night. If you have two events, A and B, and they're disjoint or mutually exclusive, which again means they both can't happen at the same time, like the 7 and 11. You can't roll a 7 and 11 at the same time. Then the probability of A or B is equal to the probability of A plus the probability of B. Exactly what I did right up here, adding the 7, probability of 7 plus the probability of 11. Only works, though, because they are mutually exclusive, all right? So let's just go back and talk about that word disjoint or mutually exclusive again. I've just been saying two things that can't happen at the same time, but the mathematical formula for that is if A and B are disjoint events or mutually exclusive events, the probability of A and B both happening at the same time is equal to 0. They can't happen at the same time. So if I change this problem on you and I said, like, what's the probability of getting a 7 or an odd number? There's now some overlap, right? 7 or an odd number. So they're not mutually exclusive. You could roll a 7 and an odd number at the same time, right? If it is 7, it is odd. If it's odd, it doesn't have to be 7, but it could be. So we need to figure out how to deal with this if they're not. So we have a formula here. The first addition formula I gave you back here is very specific, right? It's only if the two events are mutually exclusive or disjoint. So what we really want is a better formula, right? We want to be able to add this together no matter what. So for any two events, A and B, the probability of A or B happening. So now if I said probability of 7 or odd, okay, is equal to the probability of 7 plus the probability of odd minus the probability of 7 and odd, which is kind of weird because I know if it is 7, it is always odd. But we have to subtract the overlap in essence. So you can count the 7s. There are 6 of those. You can count the odds. So there are 6 7s out of 36. You can count the odds. There are 18 out of 36. But then you got to subtract the ones that are 7 and odds, which are actually all the 7s, right? Because they're all odds. So we're going to subtract that. So 6 out of 36. Okay, it's a little weird with the odd and 7 because all 7s are odd, right? But the idea is you got to subtract. And remember, let's go back to this. If they're mutually exclusive, that number is just 0, right? If mutually exclusive, which means we're back to that same formula, probability of A plus the probability of B. So let me just give you a couple little example problems here, and we'll be done, I think. That's it. Pretty straightforward one today. So probability of doubles or sum fours. So you can just count, first of all. Remember, if you wanted to, you can go back to your little chart here. If you're not sure how to do this, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You got 1, 2, 3, 4, 5, 6. So sometimes you just have to kind of go back and work your way, brute force is what I call it, go through it to try to find out what things. So the probability of doubles, there are 6 doubles. 1, 2, 3, 4, 5, 6. Those are the doubles. Fours are 1 and 3, 3 and 1, 2 and 2. So there's 3 fours, 3 out of 36. But remember, I counted one of those twice, right? The fours, let me change colors here so you can see this. The fours would be 1 and 3 right there, 3 and 1 right there, and 2 and 2 right there. Oops, sorry, wrong spot for that one. 3 and 1 right there. So if you think about it this way, I got the 6, I got the 3 this way for the fours, but I counted one of them twice, right? I got to subtract what they have in common, this doubles and 4, which is just the 2 and the 4. So we get 9 minus 1 is the 8 over 36. All right. A lot of it's just counting. You technically don't have to use the formula when you're dealing with like dice, but sometimes we just give you the numbers and then the formula becomes super important. So I'll finish these up quick and I'll be done. Probability of doubles or an even sum. Now, again, you can just count if you're not sure, right? So the doubles, again, is that 6. Okay. Evens are 18. Now we got to subtract the ones that are even and doubles, which are all the doubles. It's kind of like my first problem. All the doubles happen to be even. So you just subtract those original 6 and you're left with 18 over 36 or 1/2. Okay. Probability of 5 on the first die or 5 on the second die. I'm going to erase this real quick. Give me a second here to do a little bit of erasing at least. And then I'll rewrite here just so you can see it better. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. All right, so here we go. We'll call the top one the first die and the left side the second die. Question was probably a 5 on the first die. So 1, 2, 3, 4, 5, 6. So there are all the 5s on the first die. I'll change the color here on the next one. It's probability or a 5 on the second. So we go 5 on the second. 1, 2, 3, 4, 5, 6. There's those 6. So again, we got 6 out of 36 or 1/6 plus 6 out of 36. But we got to subtract the ones we counted twice, which is this little square right there. And we subtract the 1. All right, and then the last question is flipping the coin, head on the first or head on the second. Again, you could just list them out, right? Heads, 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 tails, tails, heads. You could just count them. So sometimes the formula is a little forced, but sometimes we have to use that formula. So head on the first, this would have a head on the first. Remember, or a head on the second. If they're happening at the same time, that's okay, right? That or. So this one has a head on the first or second, and so does this one. So it would be 3 out of 4. All right. You could use the formula. It would be, what's the probability of getting a head on the first, which is 1/2. Probability of getting a head on the second, which is another 1/2. But we got to subtract what they have in common, which is the 2 heads, which is 1/4. In either case, it gets us back to that 3/4. So if that's enough to get you started on tonight's homework, please let me know if you have any questions, and we will Talk to you soon. Bye-bye.